And good morning, good afternoon, everyone. Hope everyone's having a great day. My name is Zach with ATS. I'm the National Accounts Manager for the ATS SpecTool, working with engineers, design build contractors, even architects and interior designers with some of the newer manufacturers that have joined our ATS spec systems over the years. I also have the wonderful privilege of hosting our ATS University session most weeks. This is where we do a deep dive into a topic or discuss application specific, suggestions and product recommendations for various applications. Like we did a deep dive on the educational system over the summer, talking about fixtures and drains and backflow that's appropriate for that. We've done deep dives in healthcare and long-term care before as well. So we try to take a bit of a broad approach to this ATS University session. Commonly, we are providing ASPCU credits as we are today. So thankful to our partners like Watts that are able to provide accredited CEU courses and deep dives into topics of all the product that's available on the spec tool. If this is your first time joining an ATS University, thanks for giving us a shot. Hopefully you learn something. Hopefully you come back for the next one. We do these pretty regularly, 2 or 3 times a month commonly, and it's always related to product that's on the spec tool. So if you're your first time, you may also be unaware. ATS focuses on providing advanced configuration solutions so that you can select the actual product that you're going to use on your job and then download the information in any of our 10 different, free and editable spec formats. So all of ATS is helping you find the right product for the right application and providing you tools so you get the actual spec and actual product details for what you've selected versus just a general cut sheet that may be available online, which of course we've got those too. All of this is paid for by our wonderful sponsors and free for engineers and architects and contractors all across North America. And also some in the Middle East. Some of them still use our systems. Usually engineers that were in, North America and then have moved back home. But I see a number of great names here that are using our system regularly and joining these presentations pretty regularly. So thanks for jumping on again. I'll cover a couple of the key stuff that we always talk about. Everyone's recorded, muted upon entry. We will have this presentation recorded. I'll show you how you can find that recording at the end of the session. It's available just on atspec.com in our event, our webinar recording section. Additionally, this presentation, as I said, will be recorded and it is an accredited ASPE presentation. So we'll be having the attendance list sent to our manufacturer partner. They'll be sending out your accredited CEUs as well as our freely available certificates of attendance in case you are self-reporting anything like that. With all that being said, let's go into our topic today. We're going to be covering backflow, but not just a backflow overview, but the actual, some of the new technology that's coming into backflow. And to help us do that, we have Nadem Mirza from the Watts team. He's, I believe, the valves product manager. So everything from backflow within the Watts brand, Ames, Febco, but also I think PRVs, ACVs, and other valves as well. Nadim's a seasoned electrical engineer. He's got over 20 years of experience and specifically has been working on the IoT, the Internet of Things solutions that are all available from Watts. So he's the senior product manager, as I mentioned, in the valves category. Has a great wealth of experience in backflow from Watts, Febco, and Ames, and leads the smart and connected initiatives within that space. So we're going to have a seasoned expert here to answer some of your questions. Like I said in the kind of intro before we got started, if you have not heard some of the tech that is starting to go into, you know, things that you really wouldn't expect in the plumbing world. There's a lot of great new solutions that are coming available, key new features that are really improving the flow of our buildings. So I guess without any further ado, I'll pass it over to you. Thanks for joining us, Nadem.
All right, thank you. Thank you for that introduction, Zach. So just to set some baselines here, we have about an hour to go with. In my experience doing this presentation, I never finish it. It never finishes in an hour. There will be Q&A. Those of you who can stay a little bit longer should stay a little bit longer. We will try to address as much as we can. Anything that we miss, you'll have my email address, and so feel free to contact us, and we'll be happy to help any way that we can. So for today, I think where I wanted to take this was be able to talk about the backflow. I'm just making a couple of basic assumption, which is that hey, most of you understand what the backflow is, but I'm going to touch on the basis just to get in alignment with all of you. Also talk about the new technologies that the backflow that's coming down from 1930s. That what are the new technologies that we're introducing? Canadians, in my experience, tend to be a little bit better, more technology savvy. So I think that will be of interest to a lot of people. So we talk about the security. That's a big factor when you start transmitting the data overnight. And then we'll talk about the specification, what division the information needs to go in, and how to tackle that, because this is a little bit different than what that has been done so far. So, as I just said, backflow is a safety device. Today, we'll be focusing on innovation in technology and how we make sure that they're part of the next specification that you guys will be working on. So a lot of these concepts will be new or maybe new to you. Some of you may already have heard about them or made them part of the conversation already. So we will leave some time at the end and we'll try to answer any question that we have. And Zach will support when we take a water break or if there are any questions. So please keep them coming in and we'll try to answer that during a short period as a transitioning from slide to slide or taking a sip of water. So this is just basic, right? We the only purpose a backflow serves in our life is to prevent bad things from happening. Uh, the bottom line is that we don't want to send potable water from our house back to the water company. Believe me, that water company doesn't want it back. Once they have sent it to you, they make every effort so that that water doesn't come back. And what we do, and I'm going to talk about that a little bit later, that starting from all the way to a municipality where the water is coming out from the well, there is a backflow prevention device all the way coming to your sink. And depending on where you are, sometimes those sink will have a backflow prevention devices also, depending on what you're doing. The bottom line is that backflow preventer is a safety device. It's just like an electrical panel that you have in your house that may be hidden somewhere, but it does prevent electrical fires. So backflow prevention just helps us all to stay healthy. I'm going to quickly talk about what, for those of us who are new to the subject, maybe new to the subject, I should say, is that what are some of the backflow condition that may exist. So this is a back-siphonage. It's like those of us who's uh, old enough or in college, siphoning, sucking the water out of the car tank. So the concept is pretty much the same. You have a break in a line, and it basically create a suction, and it may pull the water in from the swimming pool that there may be out there, or even a worst case scenario from the lawn that where you may have sprinkled a lot of chemicals. So those things are real, they happen, and we definitely do not want to have the pesticides, chemicals in the water in any shape, form, even the dishwasher or washing machine. We do not want that back in the water supply. So I give an example of house, but if you take that example to the industrial side, it becomes a little bit more pronounced, and the chemicals that are used in industry are definitely not good for our health. The other example is the back pressure. As we heat the water up, it expands, it creates the pressure, which can be imposed by installation of pumps, which increases pressure above the city water supply, thereby forcing non-potable water in the opposite direction. So all these are example of where the back pressure, where the backflow condition may exist in our daily life, and that's what we are trying to prevent. So on the example that you see here is basically an example of thermal expansion. On the left-hand side, you show a boiler where the water is no longer hot. And on the right-hand side, what you see as the water heats up, it creates an increase in pressure and the forces water flow backwards into the city main. So what is the difference? From the backflow side, we divide the backflows into two different categories. And that's dependent on what can possibly go wrong, right? If there's a chemical plant which is using a chemical which are hazardous to health, the level of protection that you would need is going to be much, much higher. So there's a backflow for, I would say, health hazard or high health hazard. And then there's the pollution. I mean, there may be water that's a little bit dirty, that's not all that clean, but it's not a huge health condition, health hazard for us. So in that circumstances, you probably want to have backflows, and there's several type. I'm going to talk about that in the next slide, which can be used. Typically, the kind of the backflows that would be applicable in this condition, we call them DC, which has double checks. So instead of one check, they have two checks, and they will be pretty good product to use in a non-health hazard applications. But when you have a health hazard application, we strongly recommend that an RPZ or type of a backflow. It's a RPZ stands for relief valve. We have that's basically a third line of defense. The way you look, I kind of explain to people who are starting into the backflow is that the relief valve offers a third line of defense. As I said earlier, that every backflow will have two checks. If check one fails, you still have a check two to prevent backflow from happening. The relief valve offers a third line of defense where the water can, rather than being able to flow backwards, can be diverted through a relief valve that will go to the drain and provide a further protection. So those are two different basic kind of backflows that we use. Now, if you look at from the industrial side, there are three main backflows type, how we kind of divide them. So the first one is non-testable. This is the same thing as the other backflows that you see on the left and right side. The principle remains the same. For example, there is one that you see here. It's a double check. We call that a dual check just to differentiate that. Will typically be used in the water coming into your house or a building. So if there's a water meter outside the house, you will use a dual check and you will add that to the mix. This one that you see here is a hose bib. So if you have a hose in your house and obviously and you're watering your lawn, you do not want that hose to back siphon the water, the chemicals, the pesticide that may be in your backyard. So you can use this hose, and you can buy that from Lowe's or Home Depot. They're quite common, or Amazon. So the same thing here. They're different type, different application. You have a carbonation machine. You have other water applications out there. So they will have different type, different shapes. But internally speaking, they're uh, all backflow preventers. Inside, they have checks, and those checks are preventing the water from moving. Coming to the small diameter, so we divide the backflows, which are regular backflows that go in line, are mostly required by the code. It may be a little bit different in Canada. In United States, uh, backflows are required by the code. Period. You cannot get a building certification without not having a backflow. Recommendation on what should be is different from state to state in United States, or municipality to municipality, being a very diverse country. The good thing about Canada is CSA rules. So you happen to have just one standard. If it meets CSA, you should be able to use that. So for the small diameter, anything 2 inches or less, that's about 50 millimeter or less, is qualified as a small diameter. You'll see those applications from anywhere, from fire all the way going into your house, outside the building. Uh, 3/4 inch, 1 inch are common sizes. That's about, I would say, 20 millimeter, 25 millimeter is quite common size. And that's where the small diameter will typically fall into. Now, the large diameters, obviously, as its name says, are huge. I mean, some of these made of cast iron can weigh as much as 500-600 kg. Yes, that's a lot. That's 500-600 kg. So that's a lot of weight going into that, because they are trying to prevent backflow of water running at 100 psi, and it goes all the way to 12 inch. So that's a lot of water that will be flowing through that. You need to hold that pressure, and you need to hold that water in place for the backflow or the checks insides to properly work. Okay, so I'm going to shift a little bit gears on a backflow. This is a chart that every time you're looking at a backflow as an engineer, that you would look at as you're trying to define what kind of a pump that you need, what kind of how high your head is going to be, how much pressure do you need to induce in your plumbing system. So that this backflow will actually define the characteristics that you'll expect from the backflow. So mind you, this is a very important chart. Every manufacturer provides that this is different from each backflow to backflow. There's a lot that goes inside the backflow that will define this chart. Some are for fire application, others are for others for this water application coming out from the municipality. So they will have different characteristics. In this chart, I just wanted to do was break it down and kind of talk about that. What does that really mean? So first thing that you will notice is that there's a pressure drop. If you look at this line that's falling, going up like this, that there is a pressure drop, which really means is that depending on how much water do you want to flow through that, you'll have to make sure you have the right pump to be able to overcome the resistance, the friction that will be coming from the backflow itself. As I mentioned earlier, there are checks inside the backflow. Those checks are driven by springs on the back. They exert pressure on the incoming water. So once the pressure is starting to drop, that spring will help that check to close, or we're starting to see the backflow conditions start to occur. That spring will close the check. So that spring is exerting the pressure, and as the spring is lifting up and down, it is exerting different level of pressure on the check. Uh, when we design the backflow, we try to figure out what uh, flow characteristics we will want from that. So that's what will be defined in this green area. This is basically the sweet spot that this is backflow is designed for. Yellow is, hey, we can say, all right, you can operate in this rated flow. This is what has been approved by the independent agencies. And if there is an emergency like a sprinkler system, you can operate in this range. That's where the UL and FM comes in. The only thing is that you can operate in that area for a shorter period of time. So the whole hypothesis behind that is that, hey, when you have a sprinkler system open and there's a fire, the sprinkler system will need all the pressure that they can get, and they will all open up at the same time. So the backflow is should be able to manage and handle that instantaneous pressure that is rising, and be able to support the sprinkler system as long as needed. So it'll work for a shorter period of time. If you try to run it in those that space, red space, it's not going to break. But if you look at the characteristics, that how your pressure drop is will start to impact it at that rate. So, some of the things that you want to keep that in mind when you're going through this. But by the way, these characteristics are defined by the manufacturer, but here's a big but, they're approved by the third party. In United States, we use University of Southern California hydraulics department to qualify to test our backflows. And USC is considered a very good standard within the plumbing industry for the backflow. Just on a note, this is a pretty involved process. It's almost like going through an FDA and getting an approval for a drug. It's at least at minimum is a 2-year process, and it's a 2-year process from the date we have done as a manufacturer. We have done our own testing, and we said it meets all the criteria and the technical capabilities that we were looking for. Once that's done, we'll submit that to USC. USC in their laboratories, if they have time, they will start testing it on the lab and run it through their testing for 6 months period. So there you're just making sure that it's working as it is. Once the testing period is done, those backflows are installed in the field. So there will be multiple backflows that will be out in the field, and the inspector from USC will go out periodically to make sure that it's working as it is supposed to. At the end of that, they bring the backflows back, dissect the backflows, and if it looks good, they will issue a certificate. So it takes developing a backflows is millions and millions of dollars in development cost, and at least 4 or 5 years time on bringing a new product to the market. Why we do that? If you go back to my first slide, this is for health reason. It serves no other purpose. So we just want to make sure that when we put the product out, it's good and it works as designed.
Sorry, so just
Zach, are there any? Yeah, go ahead.
yeah, I was about to say actually, if you go back to that last slide, a couple of questions coming in, most of them kind of around a similar topic. And I'll kind of summarize it here. So if we were doing fire protection and our sprinkler line, we want to, and we're trying to make sure this backflow is correct. We want to know what our typical flow is and have that somewhere in the green, yellowish service and rated flow zone, but also know what our peak flow is and make sure it falls within the UL rated flow zone, correct?
Correct. So that's correct. So as I said, look at the charts. Once you have figured it out, that you'll have to work a little bit backwards. So the kind of sprinkler system that you're looking at, how much water that we need,
And
how
then,
much gallons, right? How much pressure that we need. So once you have that, then you look at the backflow, whose characteristics will meet. Here's the big thing: how to pick a backflow. Look at a backflow which is UL and FM rated. So not all backflows will be UL and FM rated.
yeah, and that's for fire protection. And if we're doing a regular domestic water flow, again, we want to make sure that we have our kind of typical flow rate falling. In this case, this, a 4 or 500 GPM would be a great typical flow for this backflow. And if we have a high peak flow that's getting up to, 8, 900, then we just need to make sure that we have an appropriate pressure available. And another question
Absolutely.
coming in, do all manufacturers' flow curves show the three zones?
It would not show it the same way I am. This was a demonstration purposes, but it will show you some. They would not have the colors. Let me put it
Yeah.
that way. But that data will be available
Yeah, they wouldn't
on
necessarily have
those.
the
Yeah,
colors, but they do show the bar for service flow and the bar for rated flow is
correct.
on, at least to my recollection, all the manufacturer cut sheets, correct?
Absolutely. Yeah,
Yeah,
that information has to be there. Otherwise, you would not be able to design your systems.
perfect. Thank you. All
Yeah.
right, let's
So
keep
so
moving along.
right. So I think that you made a good point. Is that for just the regular plumbing system, it's a little bit easier to figure out what the plumbing system. Once you figure out how many elbows you will need and what your head is going to be, you can design the pump behind it and put the backflow in there. Uh, the water flow in a typical plumbing system are very predictable. The whole system is being designed around the parameters defined. You want to keep 100 psi or you want to keep it 30-40 psi. So it's very well defined. Fire is a little bit different animal, so you just want to make sure that what are you looking for. The pressure is as every engineering design is a compromise. So you just need to know where is your sweet spot. Okay, so we're going to dip down into smart and connected. But before I go there, how we get here? How did we from 1930 we got into 2020? Uh, PVBs, so the pressure vacuum breakers, which are quite common in United States. They are required by the code in most of the places. They're typically outside and prevent the water from the hoses that we have in the backyard from coming in. In 1933, there was a Chicago World Fair. Everybody has taken a ship from Europe and was in Chicago for the trade fair that lasts for not, if not months, at least for weeks. They had new buildings. There was a cross connection incident where some hazardous waste got mixed into drinking water. Make a long story short, a lot of people died because of they did not have a good cure for dysentery, and a lot of people died going back home on ships. So that kind of brought the whole world of plumbing into that. Hey, we need to have some standards, and we need to figure out what we're going. It only took us about 50 years To figure that out, in 1974, we passed the Safe Water Drinking Act. We also passed on the low lead in 80s also, and also introduced the RPZ, that was a relief valve that we're talking about. So that was until 1982, and now we are in 2020. As Watts, I'll speak from us for our company, there was a big decision made that, hey, we need to bring these backflow into the modern time. I think that was the whole idea going behind that. So, in this consent, what is smart and connected? We know they're everywhere, as you can see in your example above. So, this is an interesting story. I'm going on a tangent that my wife and I were looking for a cooking range. And lo and behold, we found one with a built-in Wi-Fi. Now you ask, why do you need a Wi-Fi into that cooking range? I really don't know. But it was very exciting to see it. Not that you can turn it on and off, but you could remotely see that it's on or off. That means someone is cooking or not cooking on the range, and you can turn it off remotely, etc., etc. So that's the interaction of modern connectivity as far as we are concerned. And as of 2020, there were no backflows that existed. And this is again a safety device that could tell, hey, I am working as I should, or I'm not working. I think most of you know that the backflows are required to be tested at least once a year. The code may be different from one place to another. USC makes a strong recommendation that you do that. The way the process works is that a tester who's certified by the state or certified by the other agencies will go out and test the backflow, fill out forms, and send that information to the municipality, as well as you get to have the certificate. It's no different than the certificate that you see in a
Hey,
country.
Nadeem, I think you might have
Yeah.
moved away from the mic a little bit, and it's having trouble picking up.
Okay. Can you hear me now?
A little bit, maybe if you can get a little closer.
Just give me a second. How about now?
Yes, that's better.
I'm sorry. I must be using the wrong mic because I thought I was using my headphones. So,
No worries.
all right. All right. Sorry about that. So I don't know where did I get dropped off?
I think you're good to. It was only a quick second.
No worries. So coming back to the subject, as its name implies, these products are smarter than average human being, and they have the ability to sense the information, analyze, and then the data so that we can all use it. Not to make it overcomplicated, but artificial intelligence has the ability of machines to perform tasks that typically require human intelligence, such as learning, problem solving, decision making, etc., etc. For those of us who have made a run to Jiffy Lube every 3,000 miles, would really appreciate this technology. So I think that example that I was giving you was about the cars. Is that typically you will go out and change oil on a car after X number of kilometers, miles, and they will put a sticker in your car and says, "Hey, come back after so many miles." That was one way of doing it. But today, the car will tell you when it needs the oil change depending on your driving condition. So it's technology. This is not something new that we're bringing here. It's just that we are bringing the same technology, same thought process to the products that has been there for quite some time. Okay, so the question is, why even do that? There are three major drivers that's happening. One is sustainability and conservation. If you think about that, that because backflow is required by the code, every drop of drinking water is flowing through some sort of a backflow. Every drop that we're drinking is flowing through the backflow. And in the United States, we lose a lot of water. Enough water to fill 9,000 swimming pool is lost in the United States in the main breaks every 2 minutes. So that's a huge um, resource basically throw away if you think about that. So if you think about that, that if every drop of water is flowing through backflow, if you could tell how much water was flowing from the backflow one and how much is flowing from backflow two, we should be able to calculate where that water break is. That's actually a bigger issue in at least United States, where our infrastructure is quite old, that we can't even tell where that break is. So that's something that's defining that, creating sustainability. The second one is human expertise. I was talking about earlier that how a tester goes out and tests the backflow once a year. So that guy who knows how to do the testing is retiring. Some utilities are expecting as much as half of their staff to retire in the next 5 to 10 years. So a lot of people who have the expertise to do that. The question always that we were asking ourselves, how do you capture that brain power and and capture it in a way that it can be utilized by others? The third one is safety. I think we have talked a lot about safety, so I'll leave that for another discussion. Any questions, any comments, Zach, coming in?
Nothing so far. I think we're good
Okay,
to dive into the smart side.
right. Yeah, so a couple of good things that are happening with smart and connected. Uh, we are testing it every year, right? And the question is, hey, if it fails, and a lot of backflows will fail test every year, and whoever is doing the testing, he or she will fix that backflow. But what happens from the day this person leaves and the next 12 months? So one of the things that the new technology can do is it can do the monitoring of the backflow 24/7, and if something is not working as it is supposed to, it can send an alert. The civil engineering advantage, more RPCs are being spec'd in. Uh, there are backflows. They come standard with the flood sensors, and if you're using the RPZ and and the water starts to gush out of it, we will be able to know that. Same thing with the conservation is that we can stop. The technology is already available to stop that water from happening. Fire sprinkler code, they're getting more and more stringent, and how long a fire can be in operational. NFPA requires a fire wash to be implemented if the commercial system is down for more than 4 hours and 24. So we can see all those things being replicated by a smart and connected backflow. So here's a couple of technologies which are already available. And by the way, these are available across the board, even though the product obviously that I'm sharing with you are from my company, but and we all have unique way of doing it, but you can see it from the other guys also. So no harm, no foul right here. One of the most important one is leak detection. So when that relief valve starts to do the work it does, it could be, if you had a 4-inch backflow with 100 psi pressure, it could be dumping 100 gallons per minute. That's 100 gallons per minute. That's a lot of water coming in. And these backflow with the new mechanical rooms, space saving, especially if you're in a large city, will be in a mechanical room in the back of uh, where nobody will be able to see a backflow because you don't need to. The tester only comes in once a year, takes a peek, and goes away. So if that functions the way it's supposed to, that water is going to come across the room and it's going to go everywhere. Chances are, if you have a couple of large 6, 8, 10, inch, 12-inch in the same space, and one of them goes haywire, you will be coming in with a canoe next morning if you don't have a way to find out. Fire tamper, that technology has been there in many shapes or form. It's required by NFPA, and the whole idea behind that is if somebody is trying to shut the fire supply water off, we people need to be notified. It's typically to be the fire department. If you have a fire panel, it will be connected to the fire panel, and police probably will be notified. Obviously, your facilities people will be notified. They all need to do that. So those characteristics are being built into the backflow itself for many shape and many sizes. And depending on where you are, I've seen this. We have come up with this freeze alert. People who are living in Canada or who are living in New England, we don't have this freeze problem because we have a freeze coming every year. It happens, and we take care of that. In where I live outside Boston, we are going through a fall cleanup where we bring the things in, we're taking the hoses out. But places like Texas, Dallas, for example, they don't have a freeze every year, but they have their backflows outside. Um, so when they hear about the weatherman telling them it's freeze, backflow is the last thing they're worried about. Even though it's great for my business, but those backflows do go out because they freeze. And because of that freeze, there are temperature sensors that are integrated into the backflow itself, and somebody can buy a alert kit that can sense that temperature and be able to send out a very simple alert based on fluctuation on the temperature. Not, if you remember, the things don't freeze the instant you take them to below zero temperature. The last one is the pressure sensor. This is something that a lot of companies have been looking at. We have been looking at that also. The whole idea is that how do you monitor the different pressure zones in the backflow? And the whole idea is that we should be able to tell what happened, why did it happen, what is likely to happen, being able to provide some sort of a diagnostic, and at another time be able to predict what may happen. So that's testing that's going on right now. I think technology is very, very promising, and we will benefit a lot from that. So I'm going to go through some slides fairly quickly because I only have like 15 minutes left, and I want to touch bases on specifications. So we already talked about that, so I'm going to skip this slide. We talked about tamper switches, freeze detection. I think this is actually my favorite, only for a reason that we have built a lot of smarts into it. So one of the things I did want to remind our listener is all these technologies that we are talking about, all the smarts are built into the hardware itself. So all the calculation, all the sensing that needs to be done, it's being done into that hardware itself. So once it has met a certain parameters, predefined parameters by the manufacturer, it will send out an alert. So you're not constantly connected and using all your data. The only thing is connected whenever that alert is required. It will send that signal out to the cloud, and from the cloud, it will make it to your phone, make it to your computer, email, etc., etc. And that's pretty consistent even on the freeze detection. As I was saying earlier, that water doesn't freeze as soon as the temperature goes below freezing. This hardware is able to look at the trends, fluctuation of the temperatures, and if depending on the size of the pipe that they have, that how long the temperatures are staying below freezing, and at that time being able to generate the alert for the facilities people. I'm going to skip this one fairly quickly and talk about how these technologies actually connect before I get into the specs. Any questions so far, Zach?
Nothing else has come in so far, no.
Okay, all right. I hope people are here and enjoying their sandwich during their lunch break. So,
Yeah, absolutely.
right, right. So the easiest way to connect is through the cellular signal. Um, it's reason say it's easy because once you start getting into connecting it through a building management system or using the infrastructure that your facilities has or any facility has, they're those IT guys and they will come out and say, hey, what is the information that you're putting on my backbone, and if that information is kosher. How do I know someone is not going to come in through your hardware and get into our system and do some damage? So when you have those arguments, the best way of doing that is that go around the existing system using a cellular gateway that basically takes the data from the sensors and transmits that into the cloud. As I was saying earlier, that the hardware, the sensors which are at the backflow themselves, they're doing all the work 24/7. As long as they're powered, they will continue to look for leak, they will continue to look for the pressure, they continue to look for the temperature. And when those conditions are met, that's the only time that they will send out an alert uh, through a cellular signal. Obviously, the same alert can be sent through the building management system. They will have to, whoever the owner of the building is, will have to integrate that into the system. So this is example of that. This is Wi-Fi. So you can hardwire all those sensors into the building management system, or you can use the Wi-Fi connectivity to do that. In this case, this particular flood sensor, I was giving an example of Dallas home. It's designed for residential application, so you can one can use in their home, put that in their garage, and it'll continue to do what it needs to do. So coming back to the building management system, reason a lot of these backflows are being designed thinking that there will be a building management system. It is because there are tons of building management system. They already exist, from the HVAC to the burglar alarms to the video surveillance. So building management systems already are there across the board. They just exist. It's the question of what else do we want to connect into the same building management system. What we have done, or I shouldn't say, what industry has done, is basically simplified that information. The hardware is doing all the calculation. You don't need to put a lot of live streaming data on the building management system. Typically, the hardware will switch on and off. When there is a condition that are met, it'll just send out a switch. It's literally a relay that will open or close and trigger a mechanism to control that flow. It can shut the water off, obviously, or it can send an alert through the building management system. I'm going to skip this slide quickly and go to specification and how does that apply to backflow. Any questions, any comments?
We had a couple like housekeeping questions coming in. People asking for a copy of the slides and recording of the session. So I'll send the link to the recording here as well. But for everyone that's looking for a copy of the slides, just respond when we send over the the certificate of attendance, and let us know you need a copy. We'll send you a PDF version of the slides, and you can view the recorded session here that I just sent in chat at atspec.com/ATS webinars.
All right, perfect. Yeah, these are again publicly available information. This is concise, and if you guys need somebody locally to go over with you at your teams in your offices, we do have offices in Canada, in Toronto, in Montreal, and we can make sure that we can bring in some nice pizza and talk to your teams right there who could not join today. So this is the last portion, and I know I'm running behind by about 10, 15, at least 10, 15 minutes. But this is an important portion for those of us on the call who are engineers and who specify this product. So this is a large portion of this, and it brings home the technologies we just covered. And this is the most important part of the equation, as we will talk about how to get these technologies spec'd in. As you know, if it's not spec'd in, it doesn't exist. So if it's not on piece of paper, nobody's going to know that this is what you were looking for. So like any industry, we have 3 steps for the project procurement. First is product. What technologies exist? By this time, we should have the basic knowledge to be able to talk to a specifying engineer, specifying what does engineers need to put in and what section of plumbing or connectivity specification, and what's the wording, actual wording that needs to go in. And then, of course, procurement, when the bid comes out, where to get it. So the product that you're looking for, or how you do that. Most of the manufacturer will be able to help with that, and ATS does a fantastic job to have the specification, have the products, have the drawings of the product, how they will fit in. All those things are available with ATS. So this is really a great source at no cost to you guys to able to leverage that. So the first one is Division 22. It's the plumbing part of specification that covers a lot of area, including gas, drainage. This is also where the backflow preventers as well as other related plumbing equipment comes in. So being able to specify right kind of a backflow with right kind of sensors, etc., will be part of this section. So here just a couple of examples on how this all plays out. In section 22, 1100 is where the backflows will be spec'd in. On the right-hand side is an example of backflow RPS specification with the flood sensors. So manufacturers will typically provide similar verbiage that you can use and usually available online, and also obviously with the ATS. The highlighted area is the crucial part of the specification on how the flood sensors, if needed, will be connected to the broader BMS system or being used as standalone with the cellular network, etc., etc. So this is a good example to look at what it will do, what the connection options are, what the solution description is going to be. From based on my experience, if you're installing something at Apple or Microsoft or in a cloud center or a data center, they have a lot of sensitivity on the data connectivity. So you want to stay away from speccing in building management systems until and unless they will allow you to do that. So obvious choice in that case would be, hey, have a parallel network in shape of cellular gateway that does not touch anything else, and it's write only, which means you can't send the data back. The information flow is in one direction only. So when we have spec'd in the backflow with the right kind of sensor functionality, now comes the question of how that information will be shared. That is addressed in Division 25. That bring everything together. This is not specific to the backflow only, but would also have specification that would include HVAC, etc. So in 251100, in this case, we'll build upon the backflow spec going back from division 22 that we talked about earlier. And it addresses the connectivity case. I've used Wi-Fi as an example right here, and the flow of spec is pretty much the same that you saw in Division 22. We have already added the backflow in 22. However, if we need, we can add the temperature sensors and or other sensors in section 25, Division 25. Of your specifications. So here's just an example that we have for your reference. And once you have this document, you can take more look at it. But please note these are available online and are different from manufacturer to manufacturer. So coming to close to the end, here are some of the things that we always need to look at for the backflow. The ASSC and the USC that you see at the bottom, they are mostly concerned with the plumbing systems, IAPMO, as well, which is not on the screen. So FM and UL that you see when you have a fire application, in addition to USC, ASSC, you'll probably need to have a factory mutual stamp of approval, as well as the product that has been tested and certified and by the UL. So that brings me to the end of this conversation. Hopefully, this helped bring some understanding of what the new technologies that are coming into this backflow space, which is traditional and has been there for a long, long period of time. Here are some of the other things that you can look at when you're looking for new information. So I came pretty close to finishing it at 1 o'clock. If you have any questions, any comments, I'll be more than happy to answer that.
Yeah, you did great. You're bang on. And I guess with that, what I'll do is I'll actually take over the screen share here, just for a quick second while any of those additional questions may come in. Obviously, appreciate everyone's time. If you need to jump out, you can reach out to me after. I'll be able to provide this overview for you anytime. But that was a great detailed deep dive into backflow and into some of the new technologies that's coming up. Want to show you how you can find and specify the product simply and easily. So we've mentioned a couple of times, atspec.com is the website. That's where our SpecTool and our solutions are available. It's a great walkthrough guide here. They'll give you an idea on how to start, but it's all free for engineers, design build contractors, et cetera, to use. And you can sign up here or log into your account. Your account will be shared across multiple offices within your firm. So for example, let's say, we're actually working with, I'll use a different example. If your firm has multiple offices like a WSP, a NOR, anything like that, where you have offices all across the US, all across Canada, you can actually share masters, share projects within your firm, and also set up your own individual office. So there might, I know some of the firms might divide their workforce across like the time zones. So you have like an Eastern Seaboard team, a Central team, and a Western team, and you could set that up however you like. If you want help getting that going, reach out to me. I will use my team to help you get organized and started. I mentioned this early in a couple of times. You want a copy of the recording, go to atspec.com, this Architects and Engineers tab, into our Learning Hub and the webinar recordings page, and that'll help you get started. I want to mention as well, the tool that we're walking through is what our multi-branded options are. That's where we have everything from Watts to 40 different manufacturers, all available on the ATS spec tool. Whereas you also have a Watt specific version. If you're just looking for backflow, maybe you just do drains, you can go to the training resources tab and over to the Spec Hub tab here in the specification and design. And they have their Watts Spec Hub as well. Your same login works. You can have your same categories here. Once you're into the tool, you would simply search for a category or model number and make your selection. You can see you got your quick specs, projects, masters all here on the left as well. And that's the same as it looks on the SpecTool. So you can see I'm in my demo engineer account here. I've got my quick action tab here in the middle where I've got projects, quick specs, masters. These are basically different levels of folders with different levels of rules associated with it. We have quick specs, which is really just an open catalog. And then you have projects where you have location and application information. The application and location allow us to apply what we call is our rule engine. Our rule engine makes sure that you have product that meets your local code. So if different provinces, different states have different, building codes. So this would apply to your barrier-free selection, flow rates, there might be specific approved backflow for certain regions. And then you have masters, which is two different things. One, this master can align with your internal office master, and putting it on here will allow you to keep your internal documents up to date. So if a manufacturer discontinues a model, issues a change to a description, or like we had with the backflow a couple years back, we added a new feature that changed the model name and number. We would notify you, hey, your master, which includes product XYZ, needs an update, and help you get that new version. You can also have masters by application or owner group. And what that allows you to do is quickly add to your projects. So I'm going to use this left toolbar here, which you can find other versions I can explain in more detail another time, where I've got all my projects from my various offices, and this are demo accounts. It's a lot of different demos. We'll go into Backflow webinar demo that I built earlier. I made a couple of pre-selections here just to show what it kind of looks like. And then you would simply hit generate spec documents, which allows you to download like 10 different formats, even various options and configurations within those formats. And this is always downloading the exact model that we selected. So for example, we've got our long spec here in Word. Everything's open and editable. You can see we select our line size, some of our additional options. You get your compliance info. Everything can be copied and pasted into your own internal documents. But if you prefer a short spec, or if you prefer a CSI 3-part spec, there's multiple formats that fit your different requirements. We've got additional options as well to include alternatives, to include all your approved names and numbers. We've got PDF documents with, again, the submittal showing exactly what you've selected. The entire thing with ATS and our selections is making sure you get exactly what you select. So you're going to get the checked off boxes, the appropriate model name and number, and the appropriate description for everything you've got. We also have the manufacturer spec sheet embedded in the system. So again, nice title page. You get the manufacturer spec sheet. You get those flow rate infos that we were talking about, so you could find your approved products. Heck, even got brochure formats. I don't think you often see brochure formats for backflow, but if you so chose, it's available. Usually this is used on like our faucets, soap dispensers, accessories, things like that. And then final format I'll show before we go back into the selection, schedules as well. If you want to take this, put it directly on your CAD. Again, all of these are generated just by simply checking the box and hitting download. Now I want to show how you actually make a selection really quick here. So you use the add drawing button, and you can do it two ways. We have our categories and our tiles that I mentioned earlier. You can see I've got our pinned favorite categories here, backflow, mixing valves, PRVs, whole suite of products available from Watts. You can see we've got a diverse realm of products available, from air handlers and fan coils, PTAC units, to water softeners, backflow, faucets and fittings, even down to like accessories, grab bars. So whatever you're looking for is there. You can pin your favorites. You can filter down. So if you're looking for like, Div 20T, 22, or your fire protection products or your plumbing products, you can filter by division. And then once you're in your category, you'd simply make some of the selections where, again, you can now filter by the type of product. So the dual check that you mentioned in the early presentation, or reduced pressure types. We can filter by line size, standards. So if you have a certain standard you're trying to meet, and then of course you also have search functionality. So you can search for 757 if you know your favorite product, or flood. See what now. I was wondering if it would come up from that, but you can toggle the options for like the flood safe types. Once we're in our selection, we're then going to actually configure our selection. So this is the difference between ATS and any of the manufacturers' websites that are out there, and even any of the other spec tools that are out there. It's selecting exactly what you want and then getting the appropriate configured selection. So once we've done that, we've got all our selections made here. We get our updated model name and number, updated verbiage, and this is now configured to our selection. Then we'd hit add product, and we're done and good to go. And that's one of the nice aspects is, hey, I've quickly made an accurate selection. I know this is exactly what I want. You may also have those masters that we mentioned earlier. And this is one of the great new features where you can use either your firm's master or our ATS templates, which is like our masters, to simply drag and drop and be done in seconds. So if I go into our templates here, I've got a hospital that we're building here. So I'd go into my hospital master template, and you can see we've got everything from manual fixtures, hardwired, scrub sinks, drainage, fire protection, and then our mechanical equipment, where we could say, maybe I need some eye wash products as well, or my water heater sump pumps, or backwash filters or sludge filters on our HVAC and chilling lines, or simply the backflow that I need for my project. Check the boxes. Anything